Core 2 Summer 2015.
So to integrate this, the first thing we need to do is write everything as x to the power n. So we have 1/3 x to the power 1, 4 times x to the power minus 2, and minus 6 times x to the power 1/2. Now when you're integrating, you add 1 to the power and divide by the new power. And we always remember to add the constant of integration. So simplifying, we have 1/3 times 1/2, a 1/6, have minus 4, and x to the power minus 1 means we put x on the denominator. We have 6 divided by 3/2, so that would be minus 4, x to the power 3/2 plus c. Shall we start these questions by a quick sketch of the curve? And to sketch the curve, the first thing we need to know is where it crosses the axes. So it crosses the y-axis when x equals 0, so y would be 3. And it crosses the x-axis when y is 0, so 0 equals x squared minus 4x plus 3. That factorises. Remember, if you don't spot the factorise, then you can use the quadratic formula and we get x equals 3, x equals 1. So a quick sketch, and the first thing I can see is that I'm going to have to split my area into two. The area below the curve and then the area above the curve. So A will be the integral from 1 to 3 of x squared minus 4x plus 3 with respect to x. Adding 1 to the power and dividing by the new power. And that gives us 3 cubed over 3, which is 9, minus 2 times 3 squared, so minus 18, plus 3 times 3, which is 9. Take away 1/3 minus 2 plus 3, and that gives us negative 1 and 1/3. We've got a negative answer here, and that's because the area is below the axis. So the area that we're looking for will be 1 and 1/3. We now have to repeat this, but this time we're going to integrate from 3 to 4. We'll have our same square brackets. Our 3 will become the lower limit, 4 is the upper. So we're going to substitute in 4. 4 cubed over 3 minus 2 times 4 squared plus 3 times 4. Take away 3 substituted in. We've shown that that is 9 minus 18 plus 9. So that gives us 1 and 1/3 as well. So the total area is 1 and 1/3 plus 1 and 1/3, 2 and 2/3.